All right, one last thing from chapter 15, and that has to do with proton NMR. In NMR, for benzene derivatives, if you recall, what you saw was that the hydrogens were in a very special region of the NMR spectrum between 6.5 to 8.5 parts per million, okay, or delta. Okay. And this was due to ring current. Now this has to do with the fact that the pi electrons in the benzene, and we've already seen those, flow in a cyclic system that is perpendicular to and opposing the aromatic ring current here inside the ring and with the magnetic field on the outside of the ring is aligned with the magnetic field, and that causes the de-shielding of the protons on the aromatic ring, and it opposes it on the inside, so the inside is a very shielded region. And of course in benzene we only have protons on the outside of the ring. But the molecule that I have drawn to the right is 18-annuline, and you see that we have two different kinds of protons. We have the pink protons that are inside the ring and the blue protons that are on the outside of the ring. And it turns out this molecule fits our criteria for aromaticity, and the protons on the outside resonate at delta 9.3 parts per million. But the protons on the inside of the ring resonate at delta minus 3.0 parts per million. And this is taken as evidence for our concept of ring current in explaining the aromaticity of benzene rings. In fact, that's the experimental criteria, and then the phenomenological observation are the proton chemical shifts both inside and outside the ring. So this is figure 15.3 in your text. And again, if we look at a benzene ring edge on, okay, so the pi orbitals here, just looking at the top halves of them, for those on the top, we have an applied magnetic field. Remember, this is B0. Causes the flow of electrons to occur in such a way that we get what's called the right-hand rule. And remember, inside the ring it opposes that, and on the outside of the ring current is with B0. That's why the protons here on the outside resonate at very low field in a very de-shielding region of the NMR spectrum, that is downfield. Whereas in the case of annuline, those protons in the middle are very upfield. They're actually negative 3 parts per million in the NMR spectrum. This is a very important concept for us to understand. And again, the NMR data are our experimental criteria typically for determining aromaticity.